everyone. I hope you're all doing well and keeping safe. I'd like to welcome you to the webinar, Gardening Without Soil, Hydroponics for Northern Manitoba. If you have questions as we go through the webinar, type them into the GoToWebinar tab, which is on the right-hand side of your screen. You'll see a questions section there, and so you can just type in any questions you might have. Also, for your information, the webinar is being recorded. It will be saved onto Manitoba Agriculture's YouTube channel. It'll be in the Northern Gardening playlist, and you will receive a link to the recording as soon as we get it saved there. While we can garden in the north, and we can garden very successfully, this is a garden at Crossing Bay, there are some challenges that we do have, and in some cases, they're major challenges. One of the challenges, of course, is our short growing season. We really can only grow plants outdoors in June, July, and August. By September, we're already worrying about frost, just when our garden seems to be producing really, really well. The other challenge is that in many areas, we just don't have enough soil to grow the garden we want, or the soil is not the quality we need. Hauling soil in, if we can even find it, can be expensive. So, is there a way we can do something about that, or something we can do to extend our growing season and also solve our challenge with soils in the north? Perhaps hydroponics is a solution, as it moves the growing of produce indoors and without soil. My name is Marnie McCracken. I work as a farm production extension specialist. My coworker, Lori Forbes, is a client service coordinator, and she's the expert on the technology for the webinar. Both Lori and I work for Manitoba Agriculture and Resource Development out of the office in Nepal, Manitoba. Our presenter today is Dr. Sajjad Rao. Dr. Rao is an instructor, researcher with sustainability and horticulture at Assiniboine Community College in Brandon, Manitoba. Dr. Rao's research engages him in innovation of sustainable greenhouse production technologies, food systems, and in employing novel genetics in horticultural and agronomic field crops. Dr. Rao did a really informative session for us earlier this summer on greenhouses for Northern Manitoba. He also presented at one of our virtual horticulture schools this summer on how to grow sweet potatoes. And I'd really encourage you to have a look at both of those webinars. They're available on Manitoba Agriculture's YouTube channel. We're really looking forward today to his presentation on hydroponics for Northern Manitoba, and I'll turn the screen over to Dr. Rao.
Good morning, and thank you, Marnie and Lori, and welcome all of the presenters in this webinar. Hope you all are safe and healthy. So as Marnie mentioned, that this is a webinar, we are on the gardening without the soil, in particularly for the Northern Manitoba. So what hydroponics is for, looks for like for the Northern Manitoba. In general, it's like I will today in webinars, what I will include is the concept, what is the hydroponic concept is, and what the systems, different systems used in the hydroponic production, and what are the system components, and if we are using a small scale hydroponic systems, in particular for the Northern Manitoba or the remote communities. So what the systems look like, what will be the component cost, what components we will be including in that setup, and which crops or what crops we can grow in our hydroponic system, and how we can set up a small hydroponic setup. So going over these all those contents, I will hope it will be giving you an idea about the concept. So once we get the concept, so we know what the system exactly we can have in our own like community or in our area, and then what the system components I have to buy it, or from where I have to all organize those components, and what will be the cost. So it will give you a little bit of an idea to develop your or make your own hydroponic system and own your grow crops. When you talk about the Hydroponics. It is a water-based. It's a water-based soilless growing media, and it is the fastest growing sector of the horticulture industry or the green industry. In other words, so this technology provides a mean of a growing plants in a place where the poor soil or the limited land availability, as Marnie just explained. It also allows the food to be cultivated near consumer and delivered fresh on the daily basis. So if we have a setup in our community, so it will be there's no transportation is required. We can easily accessible, and it is we can produce at the level where the consumers or the community is living there. And even often we can harvest on the daily basis. So the initial investment for this might be a little bit higher. It's depending upon the system, what type of the system we are using. It needs some location, what type of the location we need it, what type of the building requirement is, what the equipment is, the power source, possibility, water treatment if the water quality is not good. So otherwise, the grower need to know about some of the aeration, about the nutrients, about the light, temperature control, how to maintain the appropriate type of a pH balance, and some pest controls. Growers have control over like every facets of the growing process and must fully understand the crop needs and carefully monitor their system to just to keep the healthy and productive. If it is not properly monitored, so definitely it could be a problem either by a disease or by either come over by this system. So as I mentioned, the concept is not new. It's a very old concept. So if you look at the old concept, the picture you see on this first screen, you see there is a there's a gardens made on a raised bed on a floating beds, and there's a crops growing on. So basically the concept is they are getting some water content or the moisture content and growing on the lakes. So same way it's like in the 11th and the 10th century when the Aztecs developed a floating garden that resembles the hydroponic system that what we are using today as a technology. So they build like rafts with the roots and reeds, toppered them with them soil and floated them on the lake. So the crops are grown in the soil and grew as the rafter drifted around the lake. So it's getting some moisture and air and some oxygen, and the crop is growing over there. So this is over the time, over the centuries, it gets like a little bit refined and it comes into a new technology which is now almost available everywhere. If you talk about the Canadian greenhouse system and the hydroponic system in the Ontario, in the southwest of the Ontario, there's a town called the Leamington. It's a full of the greenhouses which is growing on the hydroponic system. All the cucumbers, all the tomatoes, all the bell peppers, and most of the crops is all coming from this greenhouse system which they are using as an hydroponic system in their greenhouse systems. So when we talked about the cost, as I mentioned, the location or the building or the area, what we need to do, equipment, some power source, and all those things need to be will be the some basic cost or the initial cost. There are different systems. So when we talk about this system, so mainly there are 6 to 7 different types of the hydroponic system. Some of them very popular in a greenhouse industry. Some of them they are in a small scale industry. Some of them in a very small industry at the local basis or in a community basis or a very in say some very limited basis. So it depends upon the needs. It depends upon the resources. It depends upon the component or depends upon what we can access to make this system. So mainly there are 7 main types of the hydroponic systems. Each system has its own like advantages and disadvantages. Some methods or the some are like using the misting system. Some of them they are using the growing substrate. The other may use only the liquid. So, however, all the methods grow plants without the using of the soils. That's the main concept. So they don't use like a soil. They don't need a land. So that's what it is. It is all about. So each method provide like oxygen to the plant's root, a nutrient solution. Definitely, a nutrient is required. A proper pH to ensure the optimum plant growth and the quality. And by having these, so these are like systems like the a wick system, the ebb and flow system. The other one is called the drip system. It's a nutrient film techniques. So it's a different types of this system. So the first one, if I talk about the wick system, this is the simplest one. It's a passive system, so used as a wick that is fed into a reservoir filled with a nutrient solution. So it's already a nutrient solution is already there. The plants are suspended in a tray filled with a medium or some aggregates, whatever you choose. The nutrient solutions transfer from the reservoirs to the plant material suspended in an aggregate through the wick. So it's like by the wick, it's the water is pulled up against the force of gravity through the process of the adhesion, and then it's meet the needs of the plants for its growth. So that's one of the very simple and the basic system. The other one is the ebb and flow system. In this method of hydroponics, in which the growing chamber, or you can say it's a tray, which holding a plant is periodically flooded by a nutrient solution, and then it's all drained back into the reservoir. So it's come back. The nutrient solution contains some elements such as nitrogen, phosphorus, potassium, or other minerals. So, and they come back. The reservoir tank, the hole which is in here. So that's uh, hold the nutrient solution, and the growing chamber perches above the reservoir. The nutrient solution is pumped into this space, and then it's come back again. So after making the nutrients supply all the solution going into the area, and the plants get all the nutrient solution. So that's called the ebb and flow. So it's coming back. But main point is that we need to maintain the pH. We need to maintain the nutrient in the reservoir. So that's a key thing. So it's not like once plants are getting in all the nutrients, it will come back. It won't have the same type of a nutrient. So we need to maintain that. The other system is the drip system. So this is it's mainly used in the greenhouse industry, uh, in production of different crops, especially in the tomatoes, peppers. So it's like a very precise type of an irrigation or a nutrient solution is being provided, or targeted plants giving to a targeted plant. So in this system, they use a reservoir or a liquid nutrient solution. So in this solution, and it's pumped into a series of a thin tubes, which is called the drip lines. So going from a header pipe, and from header pipe into a small thin pipes, and individually each is delivering a nutrient solution to the plants, and then it's come back again, drain into the reservoir. So that's is similar to the previous one, which is the ebb and flow. But in ebb and flow, it is giving, if I'll go back, you can see there's no small individual drip lines going into the each. The solution is going through it and passing through the whole chamber or the container, and it's coming back. So plants, they just take a nutrients from the solution, whereas in this system, it's an individual drip line with an emitter. They are just keep dripping, and it's also a controlled. So I will come to that part at the end. So how we can control the irrigation or the nutrient solution supply system for a half an hour, for an hour, how many times in a day. So we'll come in a demonstration, which is coming in the next slide. So the next one, the after the drip, is nutrient film technique. So in this one, it's almost the same. You won't see like much of the aggregate. It's just like, roots are suspended in a system or a growing chamber, where the liquid nutrient solution is being pumped and aired out, and the plants are getting being soaked or get some wet, and they get a water from those, and they are just hanging in a solution. That's called a nutrient film technique system. So they resemble with each other. The only thing is that how much we are supplying a nutrient solution to a plants. It depends upon different plants as well. We will talk later. So if it is a tomatoes, or it's a cucumbers, it's a pepper, or it's a lettuce, or it's a leafy plant, so different systems works better for a different crops. So when we talk about water culture system, this is the again main simplest one. It's like in this one, it's a light plastic or a foam tray. Any foam trays containing the plants. You can just put plants on the foam tray, float on a nutrient solution. In this one, there is no circulation of water is going on. You need to change frequently. Once the plants are grown, you need to change, but you need a supply, oxygen supply, or pump which is pumping in that water. If you're not changing the water like an ebb and flow or the drip irrigation system, but at least you need a pump to supply oxygen, because oxygen is important. And then might be it's a little bit a shaking on the layer on top, you will feel it, but you can balance the water on top. So it is just like a very system. Leafy crops, they grow well in that type of a system. Same system modified with a deep water culture system, where the main reservoir or the series of the bucket is being given a nutrient solution. So the nutrient solution is pumped through the tubing and goes into the series of the bucket and coming back into the main reservoir. So it's again, it's like a called a deep it's a deep water culture, because it contains a more water as compared to this previous one, which is if you have like a 6 inches of a water filled in a container and on top you put a styrofoam or any other foam, which we can use as an inert material. So it's not providing any other thing, even like even any chemical. So that's good as well. So we can use any of the system which looks better in terms of our resources, cropping system, and other structures. The in aeroponic systems, basically the plant's roots are suspended in the air and misted like frequently with the nutrient solution. This system does not use any type of the growing media, so they're just suspended. This method requires a great deal of, like, you have to supervise a lot and constantly suspension or training of the new plants, and the roots are needed. It's not very much used in the in a hydroponic system, but still some crops has been grown in this way as well. So having these six, seven systems, so including the ebb and flow system, wick system, the drip system, the nutrient film systems, water culture or a deep water culture system, or either an aeroponic system. So we need some components for them. So these are some very basic, very general type of the component I have listed in here, which is the air pump. Definitely we need it for whatever the system we are using. So it is to providing some bubbles, some air. So so used to pump air from the surrounding environment into the airline, connecting into the air stones or the bubblers. So airline or the tubing, it could be a polytubing used to deliver the oxygen or to the nutrient solution, often to an air stone from an air pump. Same way, a bubbler, a piece of like a porous stone used to diffuse oxygen into the nutrient solution. Chiller, similarly, the drip lines. So it's a tubing used as a deliver nutrient solution to a nozzle, could be in a header pipe, which is like in a 1 inch, and then from a small drip lines, which is like in a 1/4 inch type of a plastic or a poly tubing that can be used. Uh, Drip manifolds, growing trays, growing chambers, as we need, what we require. Different like materials, we can use it. We can use some plastics, we can use some metals as well, as long as we are not holding a water in it, it's not rusting or having any properties of becoming a rust or carrying a rust. Some misting nozzles or some emitters which drip the solution frequently, nutrient pumps, and some like containers or the reservoir which can hold your nutrient tanks. So these are some of those very, very basic things. So these are materials, basic material. But other than this material, we need to have a good like in a climate control, how we can use to control all those microclimate around those plants to maintain the growing air temperature at an optimum level for the plant growth. Or climate control may be used to add or remove the heat from the growing area. Similarly, the CO2 or the carbon dioxide system, so used to increase the level of CO2 if there is not sufficient carbon dioxide in the growing area, to supplement or to promote some photosynthetic output. So we need some carbon dioxide system. Similarly, some basic lights or some additional light we need to have a proper par light, which is a photosynthetic active radiation where the photosynthesis can happen. So we need some artificial lighting source used to provide a good supplemental light for the crops to grow. nutrient solutions. There are a lot of options available. It's like complete nutrient solutions are available in the market. So with macro and micronutrients, they are available, but we need some small equipment like pH meter or EC meter just to maintain the pH of the solution and the EC of the solution, and obviously the pest control solutions. If there is a pest control, if it is, then we need some like pest control option. There is an option for the biological as well. There's a small options we can use as a biological. There's some sprays are available, some the best way to control the biological is just to make a sanitized area. It's a sanitization is the most effective way, not bringing any other material into that chamber on a growing area or in that small greenhouse where the production is going on. So it's the one of the best and the cheapest way to control. Otherwise, biological, there's a lot of biological availables in the market as well. And to control all of those one, there are timers are available. Even those small timers, they are available on like in a Canadian Tire or a Walmart. It's not very expensive. They are really easily accessible and easily can be used for any type of the system what we just discussed here. So when we talk about the aggregates or like to give to plants to support, so it is we can use a coconut coir. So it's like in a it's not giving any additional nutrient or any additional thing. So this is just like in a lightweight organic matter which is made up of a cocoa husk, or a hydroton is a pelletized expanded clay material. We can use that. We can use the perlite, which is a white volcanic rock material, to just to give to support to the plants, or a pine bark, or a river rock. So or a rock wool, which is unlike an expanded plastic rock fiber material, which is I will say is a cocoa coir and the rock wool. These are the main of the hydroponic in the hydroponic system. These are the mainly used. And some in like vermiculite is being used, but what I have seen in the commercial industry is mostly using the rock wool block and the rock wool slab, and which I have shown you in the next slide as a demonstration as well. So this is a all about like system components, about different systems, what we require, and in terms of like different equipments. So what different equipments or different components we need for a small setup, and what additional systems or control method is most important for the hydroponic system, and what different types of the aggregates we can use to give a support to the plant roots or holding the plants itself. So now if we talk about the small scale hydroponics, so these are the pictures from my greenhouse. So we always do a small hydroponic setup for the students as well and for the demonstration as well. So there's a two tables, it's a metal tables, they are combined, and we are using a small east trough for the collection of the water, and there is a reservoir tank you can see in the black in here. So it's like a very simple, just buy it from the Home Depot. We just made it, we cut it, fix it with a wood piece here with the two tables, and you see there's a two slab. So this is basically I'll just see. So you'll see this is like a material which is an insulation board which can be accessed from the Home Depot or Home Hardware or any local store. So why I have used, because there's a mesh wiring on this table, and to just give a smooth setup. So I can make a smooth setup and a little bit give a tilt on either side, either on the north side or on the south side where I collect the water. So it's we'll give a little bit of a tilt, or a little, or we rise, or we give a little bit height on the one end, which is opposite to the end where we are collecting the water. So water is coming back. So it's a little bit of a height coming from there and it's coming in here. It's not very significant. So it is a small incline. So just when the water comes to the plants, so it's moved back and come into this draining system, and it's come back into this reservoir. And from there, it will pump back again into to the plant. So I will show. So this is the material, what we use it. It's simple. It's not expensive. Uh, there's a cocoa material, and there is some rock wool blocks is being used. So there is a plastic or a poly sheet. It could be a single if it is a good strength, or if it is a not, then you can make a double poly on these both boards or both tables for a small setup. And just on the top of this one, having a poly first, and then put all these rock wool block and the rock wool slabs. So it depends upon how big you wanted to make it, how many slabs you need it, how many blocks you need it. So in the next picture, you can see this is a small setup. So these 3 blocks, they are not being used for any plants. They are just to maintain the distance between the plants or between these two rock wools, these cocoa slabs. So they will maintain it, because once the plants get starts bigger and bigger, so it will definitely will make some, or when it's get like a nutrient water passing through it, so might be there is a chances, so they will just displace their location. So that is why they were just put in between. So anything can be either the wood block or any other thing can be, or a piece of a wood or a lumber can be fixed in between these blocks, so just to make an equal size, give an equal distance to each plant, because that is important. Because when the plants starts growing, we need a aeration. The plants get air from bottom and it's going up in the air, so there shouldn't be a pest problem. There shouldn't be a more humidity in the bottom or a high humidity on the upper level. So just to create a good airflow within the plants vegetative area and in the fruiting area. So that is why this distance is important. So this is a regular pump, can be buy from any store. As I mentioned, Canadian Tire, there is a solenoid wall here. So we place these 2 pumps and a solenoid wall. This solenoid wall is important for opening and closing. The pump, we can run continuously. It will just running and keep throwing water back into the system, but it will not give to the drip line, or it will not give to the nutrient solution line until this solenoid wall will allow, and it will be monitored by a timer, which I can mention, which I can show you in the next slide. So there is a timer. So some small timers, easily like $60, $50 timers for a 1 or 2 time, which can continuously, you can time your water solution, which can pump in a day, like 1 hour in the morning, 1 hour in the evening, and then it will work good for you. Or might be some multiple hours you can use, like different programming. So it is a little bit of an expensive, but if we can afford, and if we are producing our crop regularly all year around, and we know that can be is an affordable, and it will make the cost in our production, and it is worth doing that. So definitely we can go for a little bit of an expensive timer as well. So this is a small setup again in the greenhouse. So small timer, and this timer is holding with the power going to the solenoid valve, which automatically turn on and off. And this is the main tubing. So you can see the black tubing with 1.5 inch tubing or an inch tubing, depending upon your system. It's a bigger, it's a small, it's a medium. We can use these ones, small hardware clips. We can use it. And from these reservoir tank, we just go through all around this big 1/2 inch tubing, and from there, as I mentioned you, in a drip irrigation system, each individual block. So this is the rock wool block, which is placed on this cocoa fiber and giving a strength and also giving a hold to the seedling. So once the seedling is placed on this block, so roots all is going to expand automatically. So once it is expanded into the block, from the block it goes into the cocoa fiber slab, or it's in a rock wool slab, and expanding and getting a water and nutrient solution from there. So that's the basic idea, or the basic component, which can be used at a smaller scale, with a less resources scale, with a small area, I will say, or depending upon the system. So if you look at a glance, so this is the, again, reservoir with a pump, with a timer setup, with a solenoid valve, and is distributing the water, and the water coming back, whatever is coming from the accessible water from the roots, after it's coming and it's collecting into the yeast trough, and from this yeast trough, and it's coming back into the reservoir tank, where the, now again, I will just mention the EC and the nutrient solution need to be maintained, because it's continuously moving and going back, and from coming back into the soil. So it will, we need to maintain the EC and the nutrient solution. We need to regularly check almost every day. So what is the EC and what will be the pH of the solution? Sometime we need to check the pH of the rock wool slab or the cocoa fiber. So the best way is to do that, just dip or put some water on this block or in the cocoa fiber or the rock wool slab and drain the water through in any container and check the pH of the water. So before and after draining those ones. So you know what the pH of those material which we are using. So we can adjust those pH according to what the number we get it. This is again from the side views. So once the drip lines is in place, so say plants starts moving, we need to give some support to move on. This is cucumber plants you can see his, which is just like a few weeks ago we just placed in our greenhouse at ACC, and they start growing, and once they start growing and climbing we need to give a support which is called the tomahawk. So this is also again available in the market, so you can adjust, you can having a longer string with that one, so you can wired up or hooked up on top till where you want to take your crop based on your height of your system where you have placed your system. So this is a very basic system and giving you an idea what exactly you need for to create an hydroponic system. This is a commercial crop growing in a greenhouse. So that's the picture I have took from an Ontario greenhouse, and this is you see this is a tomato. There's a big tomatoes, and here you can see the block in here. So it's a rockwool black. This is a rockwool slab. There is a trace going in here where the nutrient solution is just going along into the trays, and all the drip lines, individual drip line is giving a nutrient solution, and then it's collecting back into the system. So that was a commercial system. So it's in a commercial greenhouse where this water is coming back into the reservoir where it's continuously. There's a big timers, pH meter and EC meter is already being installed, and they are continuously monitoring the PC and EH of the solution. This is a closed view again of the same greenhouse which we have maintained. So this is a rock wool slab. This is a rock wool block. So it's a 3" by 3". Mostly they are 3" by 3". These are more than 2 meters of a rock wool slab. So once the plants get established here, so the roots just move into these slabs, and they are sufficient for like 2 to 3 plants on each rock wool slab. So you have to maintain the distance according to the crop what we are growing in the hydroponic system. So this is again a side view. You can see that two different crops. There is a peppers growing on, there is a tomatoes growing on, and there is there's a tomatoes and there is a peppers growing on in this system. So the water is flowing with this main pipe, the dripper bringing the pipe with the emitter which is coming in here, and then it's water coming back into the reservoir. And the pump is continuously throwing or not continuously according to what the timing we have given to the pump. Now let's talk about this. We talk about like tubing. We talk about the rockwool slab. We talk about the rockwool blocks. We talked about the polythene sheet, and we talk about the timer. We talk about the solenoid valve, which controlling how much time it's going to run a nutrient solution into the system. So let's talk about a little bit of a cost. So I've just talked some like an average cost if we have a 1/2 inch poly tubing we are using, which is you can see here, which is going in here. This one is a 1/2 inch poly tubing. So that's cost about like a 60 cents a foot, or like a 400 foot roll is around 240. This is like pricing from where we get. So this is an approximate. And for the 1/4 inch poly tubing, it's like $102 for a 1,000 feet spool. So you can get it and we can use it in a small tubing system. So there is a drip emitters. So it's each $1 each. 150 mesh filter, which is around $10. It's one small fountain pump. Could be price can be variable from $30 to $50 or $60. So this is just like an about a rough approximate price. I have just put a $40. Cocoa slabs is like $16 an each. Rockwool slabs is $2 an each, so it is a little bit cheaper. And same way Rockwool blocks, I think this price might be a little bit higher. So I have to check, or the different sources are giving a different prices. So Rockwool blocks, which is these ones, so Rockwool slabs, and this is the Rockwool block. So Rockwool block is almost like in $1 each. So the solenoid wall is $40 approximately. So now if you talk about this system who is running all this one in a small scale basis, so we need a controller, timer, and a valve. So they are all different prices. So various controller that activates the solenoid valves, which is, I already mentioned the price for is $40, ranging from $100 for a two valve controller. So if it is $100 or close to $100, it will control two valves at a time. Or if you go for an expensive one, it can control up to the 8 valves. So they give the system like a good variety of a starting time or closing time, usually rated like 16 or a 32 start times per day, and a run time as short as 1 minute. So it gives a flexibility of adjustment of all the nutrient solution depending upon the crop requirement, what type of the crop we are growing. So it's all depend upon, but it's flexibility. So if you go for a two valve controller, it's cheaper. And if you want to go for a more valves need to be controlled, then it's approximately a $500 cost. The timers also limit 30 minutes runtime, which is a quite long for a watering cycle in a hydroponic system. And I have used like without the controller as well in my demonstration or in my production system at Cinnamon Community College greenhouse, which works well as like if it 2 times in a day, it's a small $20 timer will work good. Let me see where the like a small timer, that's work good as well. So if you have a small timer, which is good, and you run only 2 times a day for a 1 hour or a 2 hour or one in the morning, 1 hour in the morning or 1 hour in the evening, and it makes the requirement for your plant. And the system, the rock wool slab and the rock wool blocks you see, they are still wet, they are not drying soon, or it depends upon the plant stage as well. So definitely the plant when they are at the seedling stage, 3 to 4 leaf stage or true leaf stage, they need a less water. We can monitor or we can adjust the timer accordingly when the plant starts growing and it's like more than a feet or a 2 feet or start producing flowers. So definitely is systems the water requirement or the nutrient solution requirements increases as the plant's growth increases. So we need to adjust. So based on the system requirement crop system, so we can purchase these things. So these are some ballpark number. They are like very close numbers. So this will give you an at least an estimate or an approximate of if I need a rock wool slab or a rock wool block or a cocoa slab or a small pump or drip emitter, so what it will be cost. Now, depends upon crops. So what type of the crops? So if we are in a high returns crops, or it's a short life span crops, or we want to go year round, just like in a leafy crop, or we want to go for a fruit crop. Fruit crop means like if we are going for a tomatoes or a peppers or a cucumbers. So it depends. So what type of the crop, how many times we have to use this system, we have to make sure we have to replace some of those parts. We can't use those parts for a 2 3 different crops. So one crop is done, so we need to remove the rock wool blocks. They are already full with the roots, or might be the rock wool slabs or the cocoa slabs as well. So we have to provide those components for the next crop, or yes, for the next crop. And if you're not changing, so might be there's a problem of algae. Definitely algae is one of the problem. So if you're using a container which is covered with a black sheet, or it is already a black, so there's a less chances of developing an algae. If the pot is continuously moving, again there is a less chances. If it is stopped, there is a chances of having some algae in your hydroponic system. So one has to keep, or the grower has to keep an eye on those things as well. This is some commercial picture. So it's like commercial setup. You can see here all these rock wool slabs, rock wool blocks, different drip lines. They are all going on. This is all on hydroponics. It's all soilless. It's a totally soilless media. It depends upon the greenhouse. It depends upon the production system, which system we wanted to use. So we need to buy, or we need to make those arrangements for our cropping system. So it's not only the tomatoes, peppers. You see, there's an eggplants. The eggplants are growing in the hydroponic system. So it's a choice. So there's a different leafy crops. They grows well on the hydroponic system. So fruit crops, They grow well on the hydroponic system. Now there are a lot of crops we can grow on a hydroponic system. The only thing is the system requirement should be good, compatible plant requirements in terms of its nutrients and in terms of its supports. If it is a viney, if it is a climby, so we need to provide that support as well. So it depends what type of the system, what type of the crop you wanted to use. So I think that's all about the hydroponic systems, components, and some cost if you want to make a small system, like as I've shown you here, in your own small room or in a small greenhouse where there is an adequate place is available, so room is available, table or benches are available, the lighting systems are there where we can maintain the micro environment which is favorable to the plants which we wanted, which we have selected or wanted to grow. Then it's a good system to grow any crop without having a soil. So thank you very much for listening. And if you have any question on the hydroponic systems or its components or any other questions, so feel free to email and get back to me. I will be happy to answer as much as I can. Thank you very much.
Thanks, Dr. Rao. Lori, will you switch the screen back to me? Thank you. Any questions for Dr. Rao? I know if you're like me, that was a lot of information and it's gotten me really thinking about the possibilities for hydroponics and how it might work and what we might need. Any questions for Dr. Rao? Certainly, as you think of questions you might have, feel free to email me, and you'll have my email address or Lori's email address from the invitation to the webinar. And certainly you can email one of us and we'll put you in contact with Dr. Rao. I'd like to thank Dr. Rao for that information. Like I said, it's a lot to think about and was really, really good information and possibly something that we may be able to make use of here in the North. I'm not seeing any questions. Lori, are you seeing any questions?
I do see one here. Did you see that one there, Marnie?
Oh, there's a new one I'm just getting. Just give me a sec. I just need to read what the question is. It was a thank you for the great presentation. I'm wondering where the best place would be to purchase the rock wool.
Uh, there is a like business around in Manitoba, in Winnipeg, and I think we can get it from the Winnipeg store. I forgot the name of that like business, but I can just give it to Marnie or Laurie, and you can pass on to the whoever made this question.
Okay, thank you.
Yeah.
I do know that I just Googled some of our local stores. I just typed in hydroponics to
Mhm.
see what equipment there may be. And certainly there's lots of stores
Yeah.
that carry hydroponics equipment. So, if Dr. Rao, if you think of where that is that you have purchased the rock wool, then just let me know and I will send that information out. So here's another question. What is the pH trend that it has to be monitored consistently? What is the pH?
It's yeah, it's between like an average is 6.5 is a good pH to just to maintain in general for like all of the crops and all of the solutions. So normally it is written on some of those like solutions as well, nutrient solution which is available in the market. But in general, if it is between 6 to 6.5, that's fine.
Okay, so 6.5. Hi, thank you for the presentation. Is it possible to get any documentation by email? And maybe Dr. Rao, would you be willing to share your presentation with me and I can
Yeah,
send it
sure.
out?
Yeah, sure.
Okay,
I will.
so
Sure, I will.
so I guess the answer to that is yes, and I'll send that out as well. Will there be a follow-up on pH and parts per million ppm levels in nutrient solutions?
Sorry, can you please repeat?
follow up on pH. I'm thinking that was answered at 6.5. And if that's not the question that you had, could that person just respond again?
So
Here's another question. And
yeah,
ppm levels in, I'm assuming this is nutrient, this word, solutions.
yeah, it's a nutrient. Like if you go for like a 200 ppm of a nitrogen, it depends upon 100 ppm, 150 to 200 ppm. It's depending upon like if you are growing for a let's say for the tomatoes. So mainly in some varieties, they are good for like 200 ppm of a nitrogen is good. So parts per million. And some is like 150 is close to 150. If I give a range, so I will say it's like 150 to 200 ppm. Maintaining that one for the nitrogen is good.
Okay.
Or like
Here's another,
yeah, there's some
sorry.
like a little bit like the first, like when you soak a block of like a the rockwool block, the pH is 5.5, the EAC is 1.5, they will seed, but at the like soon after, like after one soak or first irrigation, it will increase and it reaches to like 3 to 3.5 EC, so which is fine as well.
Okay. Here's another question. Are there any studies that indicate how large a facility would need to be commercially viable? I'm assuming, Dr. Rao, that this would depend on what you're growing. Is that
Exactly. It's what you're growing and like how much you can invest and what's your need. So that is why there's a different systems in here. Like if you wanted to grow a bigger crop, your facility is big. So again, as you said, that it depends upon the crop.
okay? Wanted to know if the pH tends to go down as the plants grow, or what is the trend and how to correct it. Oh, I see. So this was clarification on an earlier question. They wanted to know if the pH tends to go down as the plants grow, or is there a trend and how do you correct it?
Yeah, we need to add like the fertilizers, the fertilizer which we are using. Some of them they are having a good pH fertilizer, or the fertilizer they maintain the pH good level. So it depends upon different types of the fertilizer. So you need to add a fertilizers like the NPK, and then check the pH by the pH monitor and basically it's a supplementing a fertilizer will add the EC and add the pH of the water, like in a simple way if I need to answer that question.
Okay. In the small system used in the example, how was the
Mhm.
solenoid valve used and how does the carbon dioxide system look like or work?
Uh, if you look at the one of those slide in which I have just like a pump and there is a solenoid valve, so they are connected with the timer. Basically, there is a timer I showed on one of the slides. So big timer and there is a small timer with the power cord over there. So basically, that timer is hooked up, or the solenoid valve and the pump, they both are hooked up with the timer. So the pump is continuously running, but it's not, it's running means it's taking water uptake and throwing back into the system, but it's not opening the valve to deliver a nutrient solution to the 1 inch or a half-inch tubing. So that's the solenoid valve is working for. So the timer is saying like in a half an hour at this time, so it's automatically turned on, and the water which is already in the pump is just circulating, will start going to that system or the tubing.
Okay.
And then
Here's
from
another.
there, the small tubing going into the emitter, and then it starts keep dripping there, if it is a drip irrigation.
Okay, thank you. Here's another question. How often do you change the nutrient solution completely? Can you run it for 30 days?
Is again, it's a good question. Mostly what I do is I will change in a week time, just to avoid the algae and other elements which starts depositing in the nutrient solution, and it starts choking the system as well. Because if they are using a system and it's an open system, as you see, there is a benches on top of the benches, the plants is growing, some of those plants leaves or anything is coming back onto the bench or the plastics, that sheet, and it's coming back into the reservoir, it's coming into the pump. Although pump has a small filter, so we need to change the filter, not change, or even you can say we need to clean the filter. So once in a week, looking at the filters for pump and its filter, cleaning up the reservoir if it is a small tank, which is easily and we can easily clean it up. So it's good to change after a week, but if the system is running good, pH is running good, EC you are maintaining good, it can run for 30 days.
Okay. Any other questions? Lots of great questions, lots of interest in this topic, that's for sure. I'll just give another couple minutes here, seconds,
Yeah,
so on. If
like it's
anybody
like,
has,
yeah, I just give like a small demonstration because in the northern Manitoba we have some facilities or houses or a barn where we have some like heating sources or buildings are heated, we have some light, so we can create some micro environment for growing plant. So that's a small setup which can be with a less amount, we in of as an investment we can make a small setup and run throughout whatever we wanted to grow, and it's locally available, readily available.
yeah, well, and it certainly helps to address those challenges that we have in northern Manitoba with our short growing season and some of our challenges with
Yeah,
soil availability and quality for sure.
yeah, yeah, that's right.
Okay, I'm not seeing any more questions. So I want to thank you, Dr. Rao. Like I said, that was great information and certainly a topic that folks are really interested in. And if you have additional questions, certainly forward them to me and I'll put you in touch with Dr. Rao. He's certainly the expert on hydroponics and certainly not my area of expertise. So I won't even try to answer questions on hydroponics. Thanks again, Dr. Rao. I really appreciate your involvement in today's session and sharing all that great information with us.
Yeah, thank you, Marnie. Thanks, Lori. Thanks all the participants for attending this webinar.
Okay, and so I just want to end with some more information about some resources that we do have. As you know, when you look out the window, winter's definitely upon us in northern Manitoba, and it has put a halt to our outdoor gardening activities. So now is the time of year when we turn to planning. The time of year where we read seed catalogs and gardening books, where we hunker down and we watch videos, and where we plan for what the upcoming season might look like. So on the screen, there are some additional print resources and videos that are specific for Northern Manitoba, and you might like to spend some time reading or watching those videos. They're located on the Manitoba government website, and they are on the Indigenous and Northern Relations webpage. There's major initiatives on Indigenous and Northern Relations webpage, and under that major initiatives, you'll find the Northern Healthy Foods Initiative resources. Or you can Google Northern Healthy Foods Initiative and you can track these resources down that way. So those are a listing of some of the print resources. As well, there will be a link there to a number of videos that you might enjoy watching that are, again, specific for Northern Manitoba. And so you can see the listing there, and whether it's the Northern Gardening Chat or Dr. Rao's Greenhouses for Northern Manitoba, those videos are all up on that web page. As well, as I mentioned earlier, Manitoba Agriculture has a YouTube channel, and the Northern Greenhouses and all of those other videos specific for Northern Manitoba can be found on Manitoba Agriculture's YouTube channel. We have a Northern Gardening playlist, and I would encourage you to go there and to have a look and see what you might be interested in reading about or watching, and spend your winter planning and dreaming about next summer. Thank you, everyone, and thank you for participating. Thanks for joining us today. Be well.